Okay, today we're going to start our Unit 3 math review. So I'm going to kind of briefly go over each lesson that we've learned in Unit 3 and talk about a few examples and help refresh your memory on all that you've learned over the last few weeks. So in 3.1 you learned about the properties. We have a commutative property of addition and a commutative property of multiplication. Remember that the commutative property is telling us the order in which numbers are added or multiplied does not matter. So it appears as if those numbers move around an addition sign or around a multiplication sign. For associative, for addition and multiplication, it's talking about grouping. It's the way that the numbers are grouped for addition or the way they are grouped for multiplication will not change the sum or the product. So it's important to look for parentheses, but more importantly, look at what numbers are in the parentheses. And in order for it to be an associative property, there has to be different numbers on each side of the equal sign when you're trying to solve these or identify these. The identity properties of addition and multiplication. For the identity property of addition, it is adding 0 will not change the number. And for multiplication, it is multiplying by 1. For the multiplicative property of 0, anything times 0 is 0. Next, we did distributive property. And remember that this is a property that tells us that when you have a number outside the parentheses like this, we could get the same answer, since we have a variable here, if we multiply that number, in this case 2, by the numbers individually inside. So we have 2 times x plus, and then we have the product of 2 times 3. So when we simplify 2x plus 6, we can see easily that the correct distributive property expression would be 2x plus 6 right there. In 3.3, we were simplifying expressions. So this is a screenshot from that slide. We used distributive property, and then we also learned how to combine like terms. So I gave us a couple of those. So in the first one at the top here, right here, we have 2 being distributed to the x, and then remember that's a negative 4. So the simplified would be 2x minus 8 plus 9x plus 1. They're using the grouping like terms. We did a lot of things where we circled the numbers. So we have our 2x and our 9x. That'll give us 11x. Then we had our negative 8 and our positive 1, which would give us the negative 7 we see right here. So there's our final answer, 11x minus 7. In this one here, that you can see the example being done from our notes, it was 4a minus, and then in parentheses was 4a minus 3. So when we have that negative sign or a subtraction sign either in front of a number or just in front of the parentheses, we are distributing a negative number. In this case, it's a negative 1. So the simplified form, I'll kind of highlight it down here for you, is right here. So when we take negative 1 times a positive 4a, we get this negative 4a. When we take a negative 1 times a negative 3, we get a positive 3. We came back and brought down the first term, and when you circle the like terms, the 4a and the negative 4a, they result in 0. So 4 minus 4 is 0. And so we're left simply with an integer in this case, which is a positive 3, and we know it's a positive 3 because it's behind a plus sign. Remember that if they're behind subtraction, you're doing your integer subtraction where you're changing subtraction to addition and changing the number to its opposite. So when we did one step adding and subtracting, if we look at the equation, we have a variable and we either have something added to it or subtracted from it or some form of an integer around it, and we want that number to go to 0. So we're using inverse operations and performing that operation on both sides to isolate the variable. So in the first one on the left, we're going to be adding 3 because we want to undo subtraction and then do the math. So j would be equal to negative 9. On the right, you have negative 4 plus r, and a lot of times kids will think that we're undoing addition, so we have to use subtraction, but remember we talked a lot about that additive inverse. The constant number on the same side of the variable has to be 0, so do that math. If you try subtracting 4 on both sides, negative 4 minus 4 is actually negative 8. So the only way to cancel it is to use the additive inverse to get it to 0, or add 4 to both sides. So in this case, r is equal to 30. And remember that especially in these one-step ones that are super easy, you substitute in the value back to the original equation and check your work. If we're doing a word problem, we want to be setting it up as an algebraic equation with a variable. So you're identifying the variable. It's usually what is the question being asked. Then you're putting that in the form of an expression and an equation. A lot of times in the way you've learned how to solve word problems is working through solutions. So this one's kind of starting it out for us, that if we're reading the problem, yesterday Samuel had 7, he got more money, now he has 10. Oh, that's easy. If I just subtract 10 minus 7, I get 3. Well, we talked a lot about fact families, that you have to really work hard to get this equation that you're asking yourself, you know, Samuel had 7 plus more money equals the $10 he has today. So you have 7 plus m, or m plus 7. If you're looking at the way you're solving it, you used subtraction to solve it, so you have to use the opposite of that in your actual equation. So then you could backtrack it and say, well, if I'm subtracting to solve it, my original equation must have had addition and a variable. So we want, and the variable in this case is going to be equal to this 3. So to solve this, you know, that's where we're using subtraction on both sides. And this is what we're talking about and what we've been learning a lot about lately. And then you can solve it and check your work. So you'll be asked to write the equations and solve the equations. Okay, using multiplication and division. We know that the inverse operations are multiplication and division. With one step, you have the equation, you find the variable, ask yourself what's happening to the variable, and then undo it. On the left, it's being multiplied by a -6, so to undo multiplication, we use division by -6 on both sides. And we get x is equal to 6. Make sure that you're doing your integer math correctly. On the right-hand side, b is being divided by -4, so we will be multiplying both sides by a -4 so that we can get the solution. b is equal to -48. Again, check your work. For the word problems, you will be identifying the variable. We're wanting to know how many packages of diapers, so that would be RD. Each package, or one package, cost $8, and we have 40. So 8 times however many packages of diapers, D, would be equal to $40. We could undo this then with division and find that the number of bags of diapers we could buy is 5 bags. And on these word problems, make sure you're having some labels as well. So divide by 8, and say D is equal to 5. Even packages would be enough of a label, so make sure you're labeling your answers. For two-step equations, you're solving them. Here it shows that you're going to be undoing the addition subtraction first. So always look to see where that constant is and what's happening to that variable. So we'll undo adding 5 by subtracting 5 on both sides. You can see that. Then we're left with negative 3x is equal to -3. So we're going to undo multiplication with division and dividing by -3 on both sides till we get our answer. This over here in the little check your work shows that substitution taking place, and you're asking yourself the question, if I substitute in 1 and I take -3 times 1 and then add 5, will I get 2? So they're continually simplifying here until they get the answer that they're supposed to get, and that's how you know that you've done it right. This will ensure that you get these problems correct. Example 2, we started out with a -x divided by 9 minus 12. So again, we're undoing that, subtracting 12 first by adding 12. Then we will undo division by multiplication. So if you have a negative fraction term like that, remember we said, let's go ahead and make that a -9. It makes it easy. Another way to see this equation would be a -1/9 of x minus 12 is equal to -23. So again, you're adding 12 to both sides. And then remember, that's like multiplying by the reciprocal of this fraction, because if you're dividing a fraction by a fraction, it's multiplying by the reciprocal. So we would multiply both sides of this by a -9/1, and that's exactly what this is. This is a -9/1. So we're doing the math the exact same way. It just depends on how it's set up initially. Remember, if it's a fractional coefficient, multiply both sides by the reciprocal. So -9/1, And then, after you've added the 12 down here, you would have your negative 11 times negative 9 over 1, and so forth to get your positive 99. And the solution would be the same for either. In this multiple step, using distributive with a negative, so we originally have this problem, 4x minus 3 times the quantity of x minus 2 equals 21. So we're going to be simplifying the left-hand side first, and we talked a lot about what that means. So we're going to distribute the 3, and if you look at the 3, it is a negative 3. So you're distributing a negative 3 to each term inside. You'll combine like terms, subtract, and check your work. So let's see what this looks like if I were to show you some of the work that I would do. I would circle that so I know that I'm distributing the negative 3. That makes it very easy to see negative 3 times x is negative 3x. Negative 3 times negative 2 is a positive 6. At this point, we're combining like terms. So we have a 4x plus a negative 3x, which simplifies down to just simply 1x. So if we subtract 6 on both sides, 21 minus 6 is 15. The coefficient of x is 1. There's no need to do an additional step other than check your work. Take that 15 back to the original problem. Okay. When we got into inequalities, we learned about inequalities in one-step equations with multiplication, division, adding and subtracting, in two-step and multi-step. So these last 3 lessons on inequalities had to do with this table. You have the symbols, you have their meaning, you have words to describe them, and then the graph. When you go to graph them, whether it's an open circle or a closed circle, and knowing the difference between them. So an example of this would be, it looks just like an equation, but it has an inequality symbol instead. So you're subtracting 5 on both sides, and you get w is less than 3. That's an open circle, and it's going to point to the left. So all the numbers less than 3. Remember, you could substitute some of those in. When we got into the multiplication and division, we filled out this table that kind of helped you see with real numbers if you're multiplying and dividing by a positive number, right? Here's your positive number right here, and here's your positive number dividing by a positive, that what results is a true inequality. But when you get into those negatives gave us a no. This is no longer true. And the way that we found out that we could fix it was if we simply flipped the symbol. So it's abstract, because we have numbers here and we can look at these and say, well, obviously 2 is not less than negative 1. So we could change it to 2 is greater than negative 1 and make it true. But remember, one of these numbers is going to be a variable. So that makes it very abstract, and you just have to remember to do that step. So we kind of summarized it. To reverse the symbol when multiplying or dividing by a negative, we had 4 different examples. In the first example, example 1, it looks like we were multiplying by a positive, so we didn't. Example 2, we were multiplying by a negative, so we did reverse the symbol. Example 3, dividing by a negative, and we did reverse it. And in example 4, dividing by a positive, we did not. So make sure that you're very conscious of your work and practice, practice, practice. For the multi-step inequalities, just like the multi-step equations, a lot of times we, drew like a dotted line down here so we can see what was going on, with these. And try to go all the way down so we can make sure we're simplifying on the right side. So if you're distributing a positive or you're distributing a negative, adding like terms, going through all the same steps that you do. And then if you can see here, at this step, I have 5p is less than negative 5, so I'm dividing by a positive and I keep my symbol. But here I had 24 is less than or equal to a negative 8m, so I'm dividing by a negative, so I reverse my symbol. And then with that variable on the right, how are you going to deal with that? Are you going to be able to graph it just like this, or do you have to flip it again so that you can see the variable on the left? That's going to be up to you and your preference and your comfort zone.